plus P and Q, like inextensible string, plus a smooth pulley, rough plane. Therefore, we're going to have friction. P has 0.2. Let's just put in here. That's 0.2 G. And Q has also 0.2 G. So Q is 0.2 G as well. Torque coefficient of friction, so mu is 0.4. And P is released. State the tension in the string before tension in the string. The end of the string can only pull, so that'll be a tension going up there, and it's one opposite tension going here. And we've got normal contact force. And we have friction going back this way. So before it's released, then we could just resolve here. And so let's do this first answer in red. State the tension in the string before P is released. So that means we don't have to, when it's a state, we don't have to do any working out. That bit will just be resolve Q. So resolve Q upwards, and that says that T equals 0.2 G, and that is 1.96 newtons. So that's the first bit done. And now I'll do the second bit, find the tension in the string after P is released. Okay, so now it's released, so there's going to be an acceleration going in here. So let's put the acceleration going in there. And it's an inextensible string, so therefore it's just like it's completely connected, and therefore the acceleration will be the same each side. And so I'm going to take the right hand bit here. So I'm going to resolve Q, and I'm going to go downwards. And that's going to give me that resultant force equals mass times acceleration. And resultant force has got 0.2 G, goes down, minus that T equals the mass, which is 0.2 times by A. That's the first one. And then I'm going to take the second one here. I'm going to resolve that going up the slope in the direction of the acceleration. So I'm going to resolve, and that's P. And I'm going to go up the slope. So I'm showing what I'm doing. Resultant force equals mass times acceleration. What we've got going up, we've got T. So it's T. Nothing else is going up the slope. I've got minus the F. I'm going to find out what F is. And minus the 0.2 G sine 30. 0.2 G sine 30. And that equals my mass, which is 0.2 also. And A. So I've done that, and if I added these two, that would get rid of the T's, but I've got an F, so I need to find out what F equals, and so therefore I've got limiting friction, so F lim equals mu R, and that means I need to know what R is, so therefore I'm going to have to resolve P perpendicular to the thing, and that's going to say that R equals, to split this force up into two bits, that would be 0.2 G cos theta. So R will equal 0.2 G cos theta. And so R equals 1.6974097191. And then put that into the F lim. That says that F equals 0.4 times by that number, which equals 0.678963917. So now that bit, I know what F equals. F equals this, so I could put that into this bit here, and then take this one and that one and add them together. Okay, if I add them, because I have a minus T and a plus T will disappear, and that will leave me with my minus F, an extra. So if I add those together, then that will give me, that's 0.2 G minus that, the t's cancel out, minus the f minus by 0.2g sine theta, and that comes to minus 1.6589, and that will equal 0.4a. And that will come to that a equals 0.752509, but that's not what I wanted. I wanted the tension, so I am to sub that into, I would put it into this equation. Let's call it equation 1, and that tells me that t equals 0.2 times the acceleration plus 1.6589, so t equals 1.809481959, or 1.81 newtons to 3 significant figures. Okay, so Q comes down and hits the ground, and P moves up the slope, so it goes up the slope for another 0.8 meters before it comes to rest. So V will equal 0 there, and it doesn't reach the pulley arm. And I've got to find the speed immediately before, so I've got to find the speed of P as soon as Q hits the ground. So I need to find out U, what U is, this the initial speed of this final part of the journey, when I now have a new acceleration going in there, a different acceleration. So that's what I have to find to start off with. So this is part 2. So I've got to find the acceleration. So I'm going to resolve going up the slope, and I haven't got a tension up. I'll just do a little diagram so you can see what I'm talking about. Diagram there, forces on here. I've still got mg going down, which is 0.2g. I've got a friction which stays the same, so that is it's going to be 0.6789, 0.6789, that number there. I've got it in my calculator, so I keep it going, and I've got R going up here, and those are the only forces acting on it. Now I can find out what the new acceleration is. So I'm going to have resultant force equals mass times acceleration. And so I've got nothing going up the slope, so I've got minus F, so that's minus 0.6789. Oh. Minus, that's 0.2g sine 30, 0.2g sine 30, and that will equal our mass 0.2 times the acceleration, which I'm trying to find. So A will equal minus 0.6789, etc., minus 0.2g sine 30, all over 0.2. 0.2, and therefore A equals minus 8.294819585. Okay, or 0. So therefore I've got that bit, and now I've got constant acceleration, so now I can work out what it is. I've got Stuva, because that acceleration will stay the same the whole time. That's going minus 8.294, etc., or 48. Final velocity we know is 0. Initial velocity is what we want to find. Time we really don't care about, and S goes 0.8. So I want the one without t, so that will be v squared equals u squared plus 2as. So that'll be 0 equals u squared. Well, it's going to be minus, in this case, 2 times that, so minus 2 times 8.29, etc., times by distance 0.8, and we work that out. That will give us that u squared equals 13.27, and so u equals 3.64303 meters per second, or 3.64, to three significant figures, and that'll be the speed with which it had to be starting off this sort of non-tensioned route when Q hits ground, no tension. So when it started off, and as soon as the tension did go zero, that was the speed with which it hit the ground. So 3.64, a little bit tricky. And the final bit is also a bit tricky. I'll do it in red, I think. Calculate the magnitude of the contact force. Well, the contact force are the two forces acting upon it. It's the friction and it's the normal contact force. So it's the combination of F and R. Okay, and so we know that R, we worked out R somewhere, which is that, and we worked out F is this. So the magnitude, this is part 3, magnitude of contact force, and that's the combination of the two contact force, the normal contact force and the frictional force, which is a contact force. So that is going to be the square root of the 1.69 bit squared, 1.69 squared, plus the 0.6789 squared, and that comes to 1.828166294 newtons, or 1.83 newtons, to three significant figures. And I hope you can follow all of that. And that's question 6 done.